be able to get more data out of Metasploit than what is traditionally printed to the screen through some of the reporting capabilities that we have. So as this goes through, we now have all of our vulnerabilities pushed in. And as you can see, we have a couple different vulnerability references. So the next thing that we want to do is look at how to use this for reporting. So right now we have some hosts in here, and if we want to get a full picture of what's going on, we can look at DB hosts and say, okay, we can find our host and it's alive, and we know when it was added, and we can go over to DB services, and we can say, okay, so let's match this up with the information that we have. And then we go over to DB vulns, and okay, so that's not necessarily the easiest way to get to all this. So instead, I wrote a host info script. And what the host info script is going to be able to let us do is to pull a full profile for a host that we have in the database and get all the information out. So there's 4 sort of core pieces of information that Metasploit stores about hosts. We've got the host information itself, which is like when the host was discovered, if it's up or not, all of that stuff. Service information, which is the basic stuff we get back from Nmap, what services are, whether or not they're up, all that goodness. We have vulnerabilities, which are pretty much a map host and service to a vulnerability type, and store a little bit of extra data on that. And then notes, which are sort of general purpose storage, and you can put pretty much anything in a note that you want to retrieve later. So the host info script that is going to be in the source that I distribute is going to be able to pull the full listing of everything that's in the database about a specific host. So let me go ahead and change this up to be the host that we were actually scanning. And so we basically specified the username and password for our XML RPC destination, and the IP address we want information for. And so this is just some quick and dirty Python, and I'm going to go over how the code works in a couple minutes. But so from here we have all of our basic information. We've got the basic Nmap information about when the host was first discovered and last discovered. And so this is important for if you've run multiple scans or something like that, you can see which scan something went in as. The port information about what ports were found. And you'll notice there's no OS listed here. Typically, if you have a couple ports open, a couple ports closed, then you'll get some OS information, but there weren't enough ports open to identify the host for sure, so I don't include it here. So for vulnerabilities, if you remember from the Nikto output, there was a lot more verbose output. Here's the verbose output that we had from Nikto that we're getting directly from the Metasploit database. So we have all of that data from before, and this will help us aggregate it. So where this is valuable is you have multiple pen testers working on multiple things, and so each person's probably concentrating on 1 or 2 things at a time. This will let you go into the database, pull everything you know about the specific target that you're looking at, and you'll have immediately all of the relevant data for that host and one little report that you can look at, instead of having to go for multiple places and possibly multiple documents to get the information that you need to really make some actionable decisions. So this just goes through, lists the vulnerabilities. There's no notes for this host, so there's none included here. So the third thing I did is for Beef, one of the things that you can do is you can really build some host profiles. But all that you know about the host while you're running Beef, which for people who may not be familiar with it, Beef stands for the Browser Exploitation Framework, and it allows you through cross-site scripting to encourage a target browser to execute code on your behalf. So basically what we can do with that is we can encourage the browser to run some fingerprinting information for itself. We can log that into the Metasploit database, and then over time we can start building a profile of, for instance, maybe a company intranet just based off a cross-site scripting vulnerability. So let me go ahead and pull that information up. So what I've done is, as Beef is going through and gathering data, it's logging it to the database. But also, as you pull zombie reports, it's also pulling any information out of the database that you have about that host. So when you're looking at a host in Beef, you actually have all the actionable information that you may need in order to be able to do real work with it. So this is the front end for Beef. Let me go ahead and I've got a got a happy little Windows box over there that I have running our sample cross-site scripting. And so as you can see, we just had a zombie pop up. So to start off with, just for basic information, we can go into our zombies and we can pull everything we already know about this host. So to start with, this is all of the basic stuff that Beef normally logs, information about what the browser is, what the operating system is, resolution, all that good stuff, and a little bit of information about the page it's on. So all of this information is now logged into Metasploit. So offline, we can get to all of this stuff. But also, more importantly, for instance, if you have a couple people who are accessing the company intranet page, you may be able to tell a lot more about what's going on with the company just based off this portion right here, which is the HTML that was on the page that had the vulnerability itself as the person who was looking at it. So you can get a whole lot more information, especially if maybe you're looking at testing an HR app or something like that. You could really have the potential of maybe mining more information and showing that maybe the HR app has vulnerabilities by actually showing people what each person was looking at on that page. So now you have all of this delicious information, and you want to go ahead and further gather information about a host. So we can click on our zombie, go into our standard modules, and find out if it's got Java or whatever. So we'll select it, send now to determine whether or not the host has Java installed. You'll see over here that module code was sent and that Java is available. And when we come back over here to our zombies, we can see that it is both here in our module results, but also here in the Metasploit information. But you can also come back over here and see we now have a bunch of notes about that host. So all of this is pulling it back and forth and really merges things together. So again, for the Beef portion, if we were to have an internal host, drop a little bit of JavaScript on it as some stored cross-site scripting, then we can really build a large profile of an organization and what types of browsers they're using. Through the auto-run plugin portion of Beef, we can start profiling what applications are installed in the browser and things like that. So I guess if you're interested in doing maybe further social engineering or further testing, you have a better idea of what software may or may not succeed. So this will let you build a much stronger profile of an organization from a different perspective than what your typical scanning gives you. So the last demo I want to do is, so right now we have some vulnerabilities, but most people are not going to want to just do Nikto. Most people are going to want to run Nessus or Qualys or something like that. Metasploit already supports a couple different file formats, including Nexpose, Qualys, Nessus, and I think there may be one or two others. But remotely, it's not easy to push that data back into the database. So I wrote a quick script to just take a file that we have from Qualys or Nessus or whatever, and go ahead and insert that into the database so that we have all of our data in one place. And again, all of this stuff, right now I'm doing it locally, but the whole point of this presentation is You can actually do this multiple people from multiple locations and have this all centralized back to a central place. So multiple people are doing this. You don't just have to be able to do it from localhost. So we're going to come back over to this window. And so I have this import file script, and I have some happy little NBE files. So pretty much for import file, it takes the same stuff as the host info does. Our XML RPC location, our username, and the file, which we're going to use the illustrious test2.nbe, and we're going to go ahead and upload that. So we just now have uploaded our Nessus information. We look at our DB vulns again. We have all that information in there now. So now we can go ahead and pull another report. And that one was for 236. And so now, based off that Nessus data that we had, which was completely different than the Nmap data, we now have all of the same information that we were able to get before. So that really allows everything to come together nicely. So at this point, I'm going to talk about code and how it all fits together for people who are interested. There's a couple different types of objects that are involved here. The first is Workspaces. Workspaces sets a chunk aside for the project that you're working on. Where Workspaces become nice is if you are doing a pen test of the same company multiple years in a row, then you may be interested in pulling your database from last year for the same thing, opening a new workspace, and then as you're looking at changes between the 2 years for things that have hopefully improved, then you can compare the two workspaces programmatically to be able to determine what has changed and what hasn't. The host is pretty self-explanatory, services, vulns, and I'm going to go into these for just a second a little bit deeper. So the workspaces are pretty much just labeled by name. The name is arbitrary. It keeps some information about when it was created at, and there's a description field to allow you to give it a more descriptive label, like, you know, Ryan's pen test from 2009. The hosts have a lot more information in them. They have all sorts of information that you can get from Nmap, like the name, exactly what flavor of OS it is, the address, and there's actually a separate field for IPv6, so you can actually be looking at a host in the context of both the IPv4 and the IPv6 address. The services, each service maps to a host, and it includes just the port, the protocol, the state. It also has some name information about what that service is, and you can also drop in some extended information, for instance, full banners and stuff like that you can pull back later. The vulns is actually a relatively small table. It has a reference to a host and a service. You have the name of the vulnerability. You actually have references for OSVDB or CVEs or whatever that relate to that. And then you have an info block where we are storing all of that extended information about the full text of vulnerabilities. So notes are pretty cool, because if you have something that's not a vulnerability but you want to keep track of it, you do that with notes. So notes have a note type, which is essentially arbitrary. If you are developing something new, you want to keep track of it, you can create your own note type. Notes pertain to services and hosts. You can have critical, whether or not it's been seen before, and then it has a data block. And you can store pretty much anything you want to in that data block. Most of the time, objects are stored, so you can actually store information, extended information about what you found. So for instance, if you're storing information about maybe vhosts that you found on a server, you can actually include an array of vhosts in that object and have all of that accessible when you go through and pull your reports. Events are important to figure out what's going on the system. Every time you type a command, an event is logged. So you have the host that it came from, the name, whether or not it's been seen, username, and then the extended info talks about what really happened. So if you have multiple people